Polymorphism, you should understand what it means, how we use it, and abstract classes and how they allow us to implement polymorphism. This session, I want to focus on interfaces and how they help us to achieve polymorphism. Okay, let's jump right there. Okay, so interfaces, the idea of interfaces. First of all, an interface, as I will show you shortly through concrete programming examples, allows us to define some set of common methods. So it has common methods. Most of the time, these common methods are abstract methods. What it means by abstract methods?
They're
not implemented. So the interface just declares this method. And then classes come along and implement those interfaces. And the major difference here is that those classes that implement these interfaces are not necessarily related by inheritance. So let me explain this in a nice way, in another way. So if you look here, I have here an inheritance hierarchy. I have here an employee and salaried employee. I might also have, let's say, another type of employee, which is hourly employee. Hourly employee. Yeah. Okay. So what is the relationship between salaried employee and employee? It's inheritance relationship. So the salaried employee extends the employee. And what's the relationship between hourly employee and employee? Also inheritance, and the hourly employee extends employee. Okay. Now invoice is another class. Another class. Now can we make the invoice inherit from employee?
No.
Why?
Invoice is not.
Yes, it does not meet this check-in condition is a. Because invoice is not an employee. Invoice does not have a first name, does not have a last name, does not have an email, does not have a phone number. It's not a person. So this does not make any sense to have an invoice inheriting from employee. Yeah. Now, but still, if we look carefully, there is still something common between these two classes. Although they don't inherit from each other, there are something common between them. What is common between an employee and an invoice? We both need to pay them. So now, if you get an invoice for your bill, for your phone, for example, or for electricity, or for water, whatever, what you need to do with that invoice? Pay it. Otherwise, if you ignore it, at certain stage, that service will be cut. Yeah. So when we take an invoice, we don't just ignore it and put it somewhere and forget about it. We have to go and pay it. Now, for employees, if you employ somebody to do some work for you, what you need to do? Pay. So what is the common thing between invoice and employee? Pay. Although they are not related by inheritance, but they have this common feature or common thing, common method, which is they all get paid. So what an interface allows me to do, I can create an interface, I define some methods in this interface, and I force all the classes to implement those methods. Are you following? That's what an interface is. So what do you think? What will be the method in this interface?
Like payment?
Like get payment amount or pay. Or if in here, let's just say get payment amount. Get payment amount. And this payment amount will return a double. And this one will be an abstract method. Why is it abstract?
Because it will have to be implemented.
Yes, it need to be implemented by the salaried employee, by the hourly employee, by the invoice. And there is no common way of implementing it. Now, for salaried employee, what will be the payment? What will be the payment amount?
The salary.
The salary they get, the monthly salary. Okay, what about for the hourly employee? What will be the payment amount? The number of hours times the hourly rate. Yeah. And what about the commissioned employee? If we have a commissioned employee, you know, these annoying employees, they try to sell you something no matter what you try to escape. They will try to sell you as much as they can
So they get paid for
because they are commissioned employees. Yes, they basically take the sale times some percentage. Whatever they sell, they get, let's say, 4% or 5% of the sale. Okay, now for the invoice, what is the amount to be paid for the invoice?
the amount of days.
The amount of the invoice, which is typically the quantity of the items you bought times the price, times plus some tax if you are some country that applies tax. That's usually how the invoice is done. Yes? You get the idea. That is the, so there is no common way of implementing it. So I create an interface, create an abstract method in that interface, and then other classes will implement the methods of that interface. So the interface allows me to force every method, every class to have that method. Okay? And the reason why I do this is because I want to take advantage of polymorphism, which I will come later. Okay, so let me show you now in concrete way what this means. I'll show you some graphical interface or some diagram, and then we will go and see how it is implemented. There's a small mistake in this diagram. Okay, so this is supposed to be get payment amount, and it is an abstract method. Okay, so you can see here the interface has this abstract method called get payment amount, and then if I go to any concrete class, you see here every one of them has get payment amount. Where is the invoice? Yes. Yeah. So the common denominator, the common thing between all these classes that unifies them is the fact that they all implement the get payment method. Okay. Now take a look at the relationship. The relationship between commissioned employee and an employee. What is the relationship? Inheritance. Okay, and this one inheritance, this one inheritance. Now, of course, employee, invoice and employee cannot be connected by inheritance because invoice is not an employee. Now, between the interface and the actual classes, there is a similar relationship. You see here on top, it looks the same. It uses the rectangle. And then the lines are dashed lines, which means this class implements this interface. There's no inheritance, it's just implementation. So the interface defines an abstract methods and the classes implements the interface. So the relationship is implement, not the relationship is extend. It just implements. So it's similar, that's why we use similar symbol in UML, but we just make them dashed in case of the interface. Also, you can see here in the class diagram, interface is marked with this what do we call them? Curly, no, not curly brace, brackets. Just brackets saying this is an interface. It's clear so far? So let me show you concretely how this looks like in code. Here, first of all, here is my interface. Forget about other ones, I will explain them. Forget about others, just let's focus on this. This is my interface. So you can see here to create an interface, it looks exactly like a class. What's the difference? It's just, we call it interface instead of class. Now, most of the methods will be abstract methods, public abstract methods. That's why you can put public abstract, but even if you don't put it, no problem. By default, all methods in the interface, if you don't specify, by default, they are abstract and public. Yeah, by default. If you want to put it, no problem. If you don't want to put it, it is fine. It is by default, abstract and public. Okay, once I create the interface, imagine the interface is just as simple as this. Just focus on this part, yeah? Once I create the interface, what should I do with the interface? Go ahead and implement it. So let's take a look at the invoice. Here is the invoice. All I do in the invoice, I'll say, oh, by the way, this invoice implements, and the name of the interface. So in here, you see, I don't use extends. Extends is for establishing inheritance between a class and a superclass. But implement is for implementing the interface. And then once I say, yes, I agree, I implement this interface, what does that mean?
I have to implement all of them.
I have to implement all the interface methods. Otherwise, the compiler will be upset. Because you promised you will implement the interface, you should provide an implementation. Yeah? Okay? So that's why in here, I have this interface. I think I can use here override. Yeah, no problem. You know, this override is just to remember. What's the role of this override? Just to remind me if I make any mistake here, says, oh, this is nonsense. The interface does not have this method. It must have some problem. Yes, it just reminds me of that. This one is really fulfilling my promise. If I don't put this one, it will not complain. But of course, the compiler will complain. Up here, it will say something. What it will say? Must implement the abstract method. And you'll be scratching your head. I did implement. And then you say, oh, you have a little misspelling there. So if you put this one, this will help you find it. Yeah, that's the advantage of putting that annotation at override. Now, if you don't want to implement, either don't implement, or you must make this one abstract. Then compiler is happy. You say, if you put abstract, what does that mean?
It means it's not complete. You have to be implementing it later.
Yes, later the subclasses will implement. No problem. This is okay. But if you don't put abstract, you cannot move. The compiler will not let you go along, unless if you provide the implementation. You might say, I already did. No, but you have a mistake there in the name. So put the override to help you identify this easily. Is clear? Now, how do we compute the amount to be paid for an invoice? Quantity times the unit price times the tax, if there is a tax. So, for example, if it is 5%, it's 5%. We do 1 plus 5%, and we time it with the amount. In real life, an invoice might have multiple items. You know, like an invoice from Carrefour, usually people don't buy one item, a lot of items. So you will have item quantity times the price, and you do the sum. Yeah? But in here, for simplicity, it's one item. And at the end of the day, if there is some tax, you apply the tax. Okay. Is clear the concept of interface and implementing the interface? Now we will do the same for employee. So we go to the employee. I will say, okay, employee, I want to also implement this interface. Implements payable. So in here, when I implement payable, the employee, the poor employee will say, I don't know how to implement this get payments method. Sorry, get payments amount. Because it depends. Commissioned employee, we do it using the sale times the percentage of commission. Salaried employee, we just close our eyes and give them the salary we agreed upon. And for hourly rates employee, we have to work out how many hours they worked. We time it with the hourly rate. So we don't have a generic way. So that's why I promise I implement the interface, but I cannot do it myself. That's why I put here abstract. Although I don't have here any abstract method, but because I am implementing an interface, I have two choices. Either implement it myself in this employee or make the employee abstract, meaning the subclasses we should implement the get payment. Yes?
Can I not go directly to the hourly employee, salary employee, and say that they implement payable?
You can, but in here, this is much better way of doing it. You do it once. Yeah, you do it once, and then all subclasses must implement this interface. So this commitment, the parent made a commitment, and the child needs to honor the commitment. It's not something strange. Yeah? Okay, so that is let's go now to the commissioned employee. So the commissioned employee extends the employee. No need to put implements payable. Why no need to put it? We already put it in the superclass. There's no need to repeat it here. Yeah? And here, we must honor our commitment. If I don't honor the commitment, guess what? The compiler is not happy. Okay? It's saying here, the commissioned employee must implement inherited abstract method payable get payment amount. Yeah? This liability or this commitment is coming from whom? The parents made that commitment. They didn't fulfill it, hoping that the child will fulfill that commitment. Yeah? So that's it. That's the idea. Now, there is no escape. If you really want to extend the parent, you basically fulfill that commitment, which is providing a method called get payment amount. And how do I do this? I go get commission times the gross sale. And then that's basically how I do it. Now for the hourly rate, hourly employee, same thing. Because I'm extending employee, I must implement the get payment amount. Now in here, we try to be fair with them. If they work more than, less than 40 hours, easy. Wage times the hours. More than 40 hours, we pay them the nominal rate for 40, and then we give them 50% extra for more than 40 hours, okay? It doesn't matter, this is the logic of the payment of the hourly rate people. Now for the salaried employee, same thing, because they extend the employee, they must implement get payment, which is super easy. All we do is return the salary. No computation to do, we just give them the salary that we promised them. Is clear? Now, we have classes from different inheritance hierarchies. They are not related by inheritance, employee and invoice. Both of them are implementing the same payable interface, which means they all implement this method called get payment amount. Now, what this really allows us to do, why did we go through all this trouble? For two reasons. One is consistency. All the classes now have common methods and all of them implemented. And this opens the door to what? This opens the door to polymorphism. What does that mean? Sorry? What does it mean, polymorphism, in this context? With the same method will have different implementation, yes. But concretely, what does that mean? What can I do now?
Now, according to the employee, we can use gift payment.
Yeah, I know, but concretely, now that I have all the classes implementing the same interface, what I can do?
So maybe I can make a list with the data type is payable, and then I can loop through the list with all different.
That is the idea. Yeah. So now payable, because it is an interface, I can create a list. What's the data type of the list? Payable interface. And then in that list, what I can store in that list? Employees and invoices. Although they are not related by inheritance, I can shuffle them in the same list. And guess what? I can look through that list and let's say print a check with that amount. In this case, we just print to the screen the amount to be paid. You get the idea. So polymorphism, we can use it with abstract classes. What is the problem with what is the limitation with abstract classes? if we just use abstract classes?
We cannot implement the same method if it's not inherited.
Yes, we can only use, if we use abstract classes, we can only use polymorphism for classes that are related by inheritance. But the classes that are not related by inheritance, let's say invoice and employee, they are not related by inheritance. They have something in common, but they are not related by inheritance. If we just abstract class, if we just use abstract classes, they will miss out. So we want them to take advantage of the polymorphism. So we need to use interfaces. When do we use interfaces and not abstract classes? When the classes are not related by inheritance. It will become clear as we see it here. As you guessed it, take a look at this. I have payables array, and what's the data type? Payable. Why did I choose the data type as payable?
Because I want to enter all the different...
Yes, because take a look at this. In this payable array, I am able to put an invoice. I am able to put another invoice and put a salaried employee, hourly employee, and commissioned employee. Now imagine I only use the abstract class. This will work for classes related by inheritance. Does it work for classes not related by inheritance? No. Should I just give up?
No.
What's the solution? Create an interface. Put the common functionality or the common methods, just the declaration, just the signature of the common methods, put them in the interface, get all classes to implement this interface. Now you can put the data type as the interface, and you can store instances of all these objects, instances of all these classes, even if they are not related by inheritance in the same list. Yeah? You see the advantage, very super clear advantage. If I just use superclass, it is still good, but only good for classes related by inheritance. Classes not related by inheritance, they miss out. How we put the smile back in their faces? By putting the data type as the interface. Yeah, now they are happy. Yeah, because they all implement the same interface, they can take advantage of polymorphism. Polymorphism here means I have a list and I can store in that list objects of classes even if they are not related by inheritance. But they are all implementing the same interface. Is clear? Okay. Not only this, of course, I can loop through, you guessed it, I can loop through this and say, I can payable that gets class name, that gets simple name. Same, the polymorphism techniques we've seen. In the first instance, I will get invoice, salaried employee, hourly employee, commissioned employee. And of course, I can call the common method. Yeah? I can call no problem. Now, what if I want to access some method that is specific to one of the subclasses? I want to get, let's say, I want to get to the salaried employee, and I want to call the get salary.
If it's the payable is an instance of...
Yeah. Yes. So what is the technique as we saw last time?
So check if it's an instance.
Yes. So I go payable is payable instance of salaried employee, and then downcast it to salaried employee, and then I can access all the salaried employees method. Yes, remember this. So in here, this is exactly what I'm doing here. So I check, are you salaried employee? Is this payable salaried employee? If yes, I downcast it from payable to salaried employee. How do I downcast it? Come in front of the variable and put the subclass name between parentheses. This will convert it to a salaried employee. And in here, because the salaried employee has been working kind of hard, I'm going to give them some pay rise. So what I'm going to do, get the salary, current salary, multiply it by 1.1, which is basically increasing by 10%, and set the salary. Yeah? And then display the new salary. Who will get this pay rise? Only the lucky salaried employees. The other ones, no pay rise. Okay, خلاص. They should work harder if they want to get more earning, right? For salaried employees, because they enjoy their coffee, because they enjoy their discussion along the corridors, we are rewarding them with an increase. Okay, you got the idea, yes? Is clear the idea of an interface? What is the difference between an interface and an abstract class? These are typical exam questions. Yes, please.
An interface can be implemented even if the classes are not related by inheritance.
Excellent. This is the main difference.
Have to be implemented through inheritance.
Yes. So the subclass and the superclass, when we use abstract classes, they are related by inheritance. But with interface, the classes implementing the interface, they don't need to be necessarily related by inheritance. That's the first thing. The second thing, both of them, in terms of similarity, abstract classes and interfaces, can we create an instance of them? No. Can you create an instance of abstract class? Yes, because they are incomplete. Because they have abstract classes. Abstract class means some methods are not implemented. So you cannot instantiate. Can you create an instance of an interface?
No.
No, you cannot, because by definition, all the methods are abstract. Yeah, we can try it, no problem. We can try it here. Take a look. If you want the compiler to be laughing at us this morning, so what it's saying, cannot instantiate the type payable. Why I cannot instantiate the type payable? Because it is an interface. By definition, you cannot. What about employee? Can I put here employee? No, sorry. Employee cannot, okay, employee. Yeah, cannot instantiate. Why?
Because it's also abstract.
Because it is abstract. Now, can I put salaried employee? Of course, salaried employee is fine. Salaried employee.
Because you have to enter the data.
Yeah. Yes, thank you. I mean, I need to instantiate it. I mean, initialize it. Whatever it expects. I'm not sure what it expects. First, last, QID, and salary. Yes. Okay, so if I come here, put another one. No problem. I can instantiate a salaried employee because it is a concrete class. It's complete. It has implementation of all the methods. Now, for the interface and abstract class can be used as data type. In fact, it is encouraged to always use the interface or class or the interface or the abstract class as a data type. No problem, because this gives you the flexibility to assign to it any subclass. You can assign any subclass. Okay. Now, couple of precisions I want to add here. You can have static final attributes in an interface. It's allowed. You can have a static final attributes. In fact, if you create an attribute, take a look at this. If you create an attribute on an interface, by default, it is public, static, and final. Public, static, and final. And to prove it, if I take this variable here, this attribute here, and try to change it, take a look at the compiler, what the compiler is saying. The final field, payable income tax, cannot be assigned. Why cannot be assigned? Because by default it is public static final. Yeah. So although I didn't put it, it is by default. In here, for the methods, what is the default? Public abstract. And for the attributes, public static final. Public, which means it is visible outside the interface. Static means it belongs to the interface. Remember static versus instance attributes. And then final, cannot be changed. Is clear? Okay.
We can make it private as well. It's okay, right?
Private, I think, let me see. Private. No.
No.
Illegal modifier, only public, static, and final and permitted. Yes. Yes, that is good question. So basically, the only thing the interface cannot have are private attributes and constructors. You cannot have a constructor in an interface. Yeah? So just to show you here, this one is clear. So we tried to put private and it didn't allow us because not every attribute added to the interface either explicitly must be public, static, final, or implicitly. You don't put it in the interface. By definition, it is public, static, and final. The other restriction, two restrictions you have, is payable, like the constructor is not allowed in the interface, which makes sense because you are not creating an instance of it. Interfaces cannot have constructors. Yeah. Okay. Now interfaces can have static methods, no problem. Take a look at this. Static methods in interface allowed. You can also have, this is a new and little bit confusing, a new feature in Java 8 and above. In an interface is supposed to have only abstract methods without implementation. But in Java 8, they decided to allow an interface to have a default implementation. What does that mean? If the subclasses or the classes implemented in the interface do not provide an implementation, this implementation will be used. Which basically reduces the difference between abstract class and interface. They become now very, very similar. Yeah? So you can have a default implementation, but you must add this keyword default. If I just put an implementation here, take a look at the abstract set. Abstract cannot specify body. Can you see it? So by default, all methods in the interface are public abstract, which means nobody, they don't have an implementation body.
So default here does not have to do with visibility.
No, not to do with the flexibility. Default here means if the implementing class does not provide an implementation, this implementation in the interface will be used. Yes? Okay, so if I put the default keyword back here, now the interface is happy. No, of course it has to be placed before the data type. The interface is now happy. And what this is doing, take a look, what this is really doing, it's taking the get payment, which is abstract, and displaying it as a string with currency symbol. Yeah. So if I come to my payable, what I can do here, so instead of putting here as a float, I can put it as a string. And in here, instead of get payment, I will do amount to currency. Yeah. And this one, this amount to currency, the implementation will be coming from where? From the interface. Because none of my methods implement that interface. So the default one will be used. Yeah. So in another way to say it, by definition and by default, all methods of the interface are public and abstract. You cannot have an implementation on them. But if you wish, in some small number of cases, if you wish to have a default implementation, you can, but make sure you put the keyword default. And what does that mean when you put that implementation with the default keyword? Sorry?
A subclass doesn't have an implementation, this is what
this will be used. Of course, the subclass can override this. Subclass is welcome to override it. But if they are lazy and some reason they don't implement it, this will be used. Now, can an interface have a static method? Yes. You can see here, static method is added, there is no problem. Static method, which means it belongs to the interface. I can call it without creating an instance of a class implementing the interface. So in here, you can see here, for example, in here, I can just come and say payable, remember payable, dot, you see here, these are my static attributes, and this is my static method. And I can give it, for example, 50. And it will display it to me as Qatar area QR space 50, 50.7. Yeah, I can do this as a static method. Okay, so I hope it's clear. So let me just jump here super quickly and summarize what we have seen. So the idea of interfaces, back to the core idea, are used to define set of common methods that must be implemented by classes not necessarily related by inheritance. They don't need to be related by inheritance. The interface specify what operation a class must perform and does not specify the how. By definition, by default, all methods on the interface are abstract. But you can implement some of them if you wish, but mark them as default. Default means this is the default implementation in case the implementing class does not provide one. Okay, and the way you use it in terms of syntax, instead of using the keyword class, you use the keyword interface. And when you want to implement an interface, instead of using extends, you use implements. And the motivation of using interfaces is that you want classes that are unrelated to have common methods. So for example, invoice and employee are not related by inheritance, but both of them have the same method, get payment. And why are we doing all of this? To be able to process them polymorphically, which means to be able to put them in a list with the data type interface, and we can go through that list and process it. Yeah? So this way, polymorphism is not Hekr, is not only limited to be used for subclasses and classes related by inheritance. It can be used, we open it up a little bit more for classes that are even not related by inheritance. But of course, they have some common functionality, some common behavior. And here I gave you the example of employee and invoice. They have a common interface, which is payable. Okay. Now, if you want to look very, very, very high level, you can even think some very, very high level interface that is implemented by all living creatures. They might not be from the same inheritance hierarchy, but all living creatures, they have this interface. Eat, move, grow, reproduce, die. These are the methods. You can think of, that's the concept of an interface. It's some functionality that is common to all set of objects, although they might not be coming from the same inheritance hierarchy. Okay? So for creating an interface, you use the keyword interface, you put in there all the methods. By default, they are abstract, public abstract, and then the classes can go ahead and implement the interface. Okay, now, if you wish, some methods, not very common, but if you wish, some of the methods, you can put some implementation, but make sure you put the keyword default in the declaration, in the signature of the function. So this way, if the classes implementing the interface have the choice. They can have their own implementation, or they can use the default one if they don't provide one. Now, what is the difference between class, an abstract class, and an interface? Okay, first of all, an abstract class both of them, first of all, in terms of commonality, something that is common between the two, both of them, they cannot be instantiated. Second thing is abstract class and interfaces, they might have abstract methods. Both of them might have abstract method, and that must be implemented by the subclasses. Okay, so the classes that implement an inheritance, the classes that implement an interface, they don't necessarily need to be from the same inheritance hierarchy. They don't need to be necessarily related by inheritance. But the subclasses implementing an abstract class, they must be related by inheritance. Okay, so a concrete class, concrete subclasses that extend an abstract superclass, of course, they are all the subclasses will be related to the superclass by inheritance. Interfaces cannot define instance attributes and constructors. We've seen this. And finally, a class can only extend one abstract class, but can implement as many interfaces as it wishes. So there is no limitation in terms of how many interfaces a class can implement, but how many classes a class can extend? Only one, because Java is a single inheritance language. So to summarize, we have been in the last 2 weeks looking into inheritance, which is a way of taking the common things from similar classes, put them in one superclass and inherit them in the subclasses. This allows us to reuse, and this allows us to reduce maintenance, because if something changes, we change it in one place. Now, inheritance opens the door for this very clever idea of polymorphism that allows us to write our program in a more general way. We can create a list, for example, with the data type abstract class or interface, and we can put in that list instances of different classes, and we can process them in a general way. So this way, it makes our code more concise, and also it makes our code more extended. If I add more subclasses, the general code processing this collection of classes don't need to be changed. So that is the idea of inheritance and polymorphism. I hope it is clear. So please go through the slides, go through the example, post questions on Piazza. This is the end of this topic.